Hi, this is Greg Hartwig, and welcome to our first game-changing technology that we're prepared to show you guys. A machine that was going to be at IMTS. This is the actual product launch of the Okuma M660. So buckle up, we've got about 10 minutes of great information to hear for you from Wade and Ed and Brad from Okuma America. If you have questions, please put them in the chat box. We will answer them in a live Q&A at the end of this session. Thank you.
Hi, welcome to Okuma America. I'm Wade Anderson, and for the next few minutes, I'm going to give you an in-depth look at the brand new GENOS M660-V. For several years now, the M560 has been the #1 selling vertical mill for Okuma America. However, today we're going to take a look at its big brother, the GENOS M660. One of the first game-changing technologies that you'll see as soon as you open up the door is the vertical spindle. This is a 199 Newton meter vertical spindle. We offer two different options with this spindle on this machine. We offer a Cat 40 Big Plus 15,000 RPM spindle, or we can offer this in a 12,000 Cat 50 Big Plus spindle. This spindle is supported with a massive frame behind it. So instead of this being a C-frame or an L-frame style construction machine, this is actually a double column bridge style construction. So this gives us a lot of support and a lot of stability to hold a very powerful spindle. This gives us opportunities to mill everything ranging from aluminums to steel to titanium, all with one style of machine and one spindle design. Our x-axis is overhead. This runs a little over 59 inches of travel. Our z-axis is overhead at just a little over 25.9 inches of travel. Then our y-axis runs to and from the operator. This is on its own separate motion system. It's not a table-on-table stack-up. One of the key things that makes this very valuable from an operator perspective is it's extremely ergonomically friendly. The table comes back and forth to you. You can bring the workpiece right up to you. We've got a wide overhead door, so for heavy work pieces, work holding, things of that nature, we can bring a crane in and crane parts into the table as needed. The table itself is a little over 60.2 inches in length and 25.98 inches in width. This gives us the opportunity to put large work pieces on the table, or we can set up multiple types of work pieces, or we could set up progressive work holding. So you could have an op 10, op 20, op 30 type setup. We could also take, this comes standard as a 3-axis vertical mill, but we can very easily add a 4th axis interface or a 4th and 5th axis interface, and we can mount a rotary table to one end of the table itself and give us a lot of real estate left to do other work pieces. So you get a lot of real estate and a very small amount, a lot of workspace and a small amount of real estate. One of the key features in the design of this machine tool, or any Okuma machine for that matter, is the thermal friendliness. We start the design of any machine with thermal stability in mind. That's one of the things that I think we're best known for, is the accuracy of the machine over time. So when you look at this machine, any Okuma mill, when you look inside it, you will never see cast iron. Our entire enclosure is lined with sheet metal. Even our chip augers on each side, we have coil auger conveyors on each side of this, and they are lined with stainless steel that allows the cutting influences, coolant, hot chips, things of that nature, to funnel outside of the machine without ever coming in contact with the cast iron itself. Obviously, anytime metal heats or cools, it expands and contracts. So from a design concept, we try to separate out all the heat sources that we can. But of course, there's going to be some heat source that we can't get out of the machining environment itself. So this machine runs thermoactive stabilizer, what we call TAS. We have TAS S in the spindle, and we have TAS C for cast iron or castings. So this machine runs actual sensors embedded to the spindle in several different locations, as well as different locations in the construction itself, that measures real time what this machine is going through during its active day of use. So every 1/10 of a degree that this machine moves, the control knows what it's doing and can automatically compensate for that anytime it hits a G0 or a rapid movement.
Hi, I'm Ed Leeson, an applications engineer with Okuma America. I'm going to feature the mid-auto manual, a very operator-friendly interaction with the machine. So we're running through a tool. We want to inspect the tool. We feed hold mid-auto manual. It engages all of our manual operation, so we can just stop the spindle and bring the spindle up. If we want to inspect the tool, change inserts, whatever's required. From here, we just close the door, start the spindle back up, sequence restart, and we're right back in the program. A common concern for a machine operator is recovery from interruption from an automatic tool change. With Okuma, we have a very simple one-step function. So all you have to do is enter the machine operation screen. At this point, all the operator needs to know is step it advance or return. So we'll step through here. And that's a complete tool change.
Hi, my name is Brad Klipstein. I'm the Controls Product Specialist here at Okuma, and today I'm going to be talking to you about our OSP P300 MA control. Our control is extremely easy to operate, easy to use, and it's built on a very powerful motion control system. It's a complete game changer for your shop floor. It's got a full touchscreen panel up top, along with a full keyboard and full operation panel. What's great about this control is this doesn't change from a 3-axis machine to a 4-axis horizontal or even our 5-axis full simultaneous machining centers. I've got 2 USB ports located on the front of this panel and allow for program upload and download. The thing comes standard with 4 gigabytes of program storage capacity. We've also incorporated a ton of nice standard features into our control to help your operators and programmers throughout the process. Things like our IMAP feature that give you built-in guides for any kind of canned cycles. We've got a ton of troubleshooting guides to aid you with anything that could be problematic at the machine tool. We've also got quick edit and background editing so that you can easily modify programs on the fly. It's built on a full Windows operating system, which means it's very easy for you to integrate any kind of automation platforms now or even into the future. The motion control system is another very powerful feature about the control, and it comes standard with 2,000 block look ahead. And that's one of the features that we actually demonstrated with High Cut Pro in that dog bone demo that you just saw. And the last thing I'd like you to know about the control is it's very easy to connect. We've got Ethernet as a standard and MT Connect as a standard interface for the control. So doing things like collecting data and monitoring everything on your equipment is very easy to do right from our control systems.
So one of the things that makes thermoactive stabilizer work for Okuma the way that it does is because we don't just build all the mechanical side of the machine that you see behind me, but we do, from an engineering perspective, we do what's called mechatronics. We blend the marriage of electrical engineering with the discipline of mechanical engineering. So when you look at an Okuma machine, the user-friendly OSP control, all the motors that drives the motion system, the spindle drives, the servo drives, all that is Okuma. When you open up the electrical cabinet, you're not seeing a third-party motor and drive system, you see Okuma and OSP system. So one other thing, the last thing I'm going to leave you with that I really like about the GENOS M660, and really this is all of the GENOS vertical machining center line itself from a user-friendly perspective, is a very simple tool access door at the front of the machine. This is very nice from an operator perspective because while the machine is running, while we're doing demos, we can quickly come over, open up the door, access the 32 tool changer, change out expired tools, put our redundant tools in, things of that nature, shut the door, and keep that spindle running. As long as the spindle is running, the shop is making money. I appreciate you joining us today. If you have any questions, we look forward to answering those at the end. Thank you.
Everybody, this is Greg here. Can you hear me okay? Okay, great. So thanks for watching the video today. Hopefully you guys enjoyed it. We enjoyed putting it together for you. It's a lot of fun. We have had a few questions come in, and I'm going to go ahead and go through them now. We have Wade Anderson and Ron Raniszewski, Ed Leeson, Brad Klipstein here on the line. So we're going to answer your questions the best that we can, and if we can't answer them, we'll follow back up with you shortly. So looking here at the first question, one of the questions was, can you network it? And the answer is yes. But Brad, can you answer that a little bit better than just a yes?
Absolutely. Thanks, Greg. Good question. So yes, you can absolutely network the machine. It comes standard with the ability to share files directly with the machine tool. So you can set up file sharing if you'd want to upload and download part programs, say from a DNC type interface directly with the machine tool. So you can upload programs from your office directly into that machine directory and share those files. So you can network the machine as far as sharing any of those NC programs. And then one of the things that I touched on in that video is the ability to pull information from the machine as well. So if you were interested in collecting information from the machine, that is a standard interface with the equipment as well. So that's the MT Connect component there that I was briefly mentioning. So you can upload and download programs, and you can collect information. All of that is going to be standard on any of our OSP P series controls. But good question.
Yeah, thank you. Next question is, how much does the machine weigh and what electrical options are available? So I want to say the machine is nearing 20,000 pounds. That's a very heavy machine. And as far as electrical options, the machine's wired 208, but we can do 480. There's a number of different options that we have, and there's a multi-tap transformer on the machine. So the hertz size, I don't really know. I'm sorry, the hertz. Ron or Wade or Ed, do you guys know what the hertz is on the electrical side?
I'm gonna think it's about at least 45 on the machine.
Yeah. Okay. So yeah, it's a very heavy duty machine, and there's a lot of weight there, to take the vibrations and dampen any kind of vibrations or harmonics that come up from machining. Greg, you say something?
Yeah, I think that's a key point. The machine, there's slightly two different weights depending on the spindle configuration. So a Cat 40 comes in at 25,300 pounds. When you go into a Cat 50 model, it's just a little over 26. I think it's 26,800 pounds for that machine. So a little bit of different components when you move into that Cat 50 category. So it adds a little bit of weight. But that's a very important part of that machine to be able to take the cuts that it does, is to have the mass behind it for the damping effect.
Yep. Next question is, what kind of warranty comes with this machine? So it's a 2-year warranty on the machine, right? And then there's a 5-year parts warranty as well.
Right. You nailed that one, Greg.
Thanks, man. Let's see, the next one. How thick the concrete do we need? 6 or 8 inches, okay. As a sales guy, I would say 6 or 8 inches is probably fine, but I'll probably get myself in trouble here. It'd probably be better for the engineers to answer that question.
Ron, you want to answer that one?
That's what I was looking in my documentation, because that's a tricky question, because it depends on what's underneath the cement.
Right.
Yeah, right. And if there's iron in there, if it's
yeah, the way the foundation's made.
Yeah.
And I'll have to get the exact number because I don't want to shoot from the hip.
And I would
So
say,
I am looking at the foundation drawing here, and it's a general reference to the foundation drawing. It's showing concrete of 450 millimeters with 150 millimeters of substrate. And again, what different areas of the country have a lot of different compositions that
lead itself to exactly what's required.
Yeah, that's quite a bit of concrete. I think that's a very conservative answer, which is typical from the Japanese. But I would say in a shop, 6 to 8 inches, John, is probably just fine. If it's reinforced concrete, that's the way to go. Another question I had is, how much weight can you put on the table?
So it's 1,500 kilograms. And I apologize. What is that in? I got to do a conversion.
3,300 pounds.
It's like 3,300 pounds.
33,
Yeah.
there you go.
Yep. Chris Peterson had a question. What were the travel dimensions again? So it's 60 by 25 is the table.
Right.
And then I want to say Z is, Wade, can you correct me? It's roughly
25.98.
25. Okay,
Yeah.
thank you.
So, and I noticed in the video, I failed to say what it was on y-axis. So just to go through all of them, x-axis is 59.05, y-axis is 25.98, and z-axis is 25.98 as well.
Thank you. How much horsepower does it have? It's a 30 horsepower spindle.
Yep.
And that's the same in the 40 or 50 taper. It's the same power. It's the same. It's really almost the same torque curve.
It is. Yeah. Same torque curve.
What acceleration, as in G specs, are the axis on this machine?
Average is 0.7 G. So they're a little slightly different between X, Y, and Z, but if you average them out, it's 0.7.
Yeah. Thank you. And then the last one we've got right now, is it a direct drive spindle?
Yes, that's a good question. That's one that I always like to talk a lot about because there's some misconception in the marketplace. Some machine tool builders will advertise an inline spindle, and that's not the same as a true integral spindle. So when you look at these spindles and these machines, it's a true integral spindle, meaning that the actual motor is wrapped around the spindle shaft itself. It's not coupled to a bearing housing. It's truly integral to the machine itself.
And would you mind mentioning about how the spindle is cooled again, the bidirectional cooling?
Yeah, so that's something I think that we do very unique in the marketplace. The way that we cool our spindles, we actually have 4 individual cooling channels on that spindle. So if you look at a spindle, you have the bearing housing down near the front. So most people, when you're looking at it, like in the video, you saw the tool. So just above the tool is your bearing housing. That bearing housing has a spindle jacket that runs bidirectional coolant. So that keeps any heat differentiation from the lower sets of the bearings to the upper set of the bearings as even as possible. And then as you go farther up, you have the motor, which has the rotor and stator. That has its own separate bidirectional cooled channel. There's a bearing cap on the back of the spindle on the very top where the roller bearings are. That's got a separate cooling area. And then inside the spindle, there's actually a cooling channel in between the 2 lower angular thrust bearings and then the 2 upper sets of angular thrust bearings. So we actually have 4 individual cooling channels to take any heat that we can out of the manufacturing process.
Thank you. Nice job. We got a couple more questions that are coming in, and I screwed up. It's not a 2-year warranty, it's a 3-year warranty. So I apologize for that. I've been corrected. So that's even better. How long can the spindle run at 15,000 RPM?
Okay, so that's a good question. You're gonna make me dig through. Let me pull something up, make sure I'm telling you the best information. So there is a calculation that we use on our spindles. Bear with me just a second.
And while Wade's looking that up, there was a question about through spindle coolant, and yes, it's prepped for 1,000 PSI, meaning there's a Dublin coupling up there and plumbing that's ready for it.
So our calculations is 20% low RPM, 60% mid-range RPM, and 20% high RPM. So when you're looking at a warranty information on a spindle, things of that nature, that's the calculation that they'll look at from a runtime calculation perspective. These spindles do run an air oil mist lubrication system. So really, as long as the machine is not wrecked, as long as you haven't run it into something, and as long as you're maintaining it, there's a coolant pin that's part of the normal maintenance of the machine. That protects it from the through spindle coolant. So as long as those things are maintained, there's really no reason for that spindle to see failures.
Thank you. I got some more that are coming in. This is great. Appreciate the interaction, everybody. What is the cost range on the 660 between a 3 and the 5 axis? So that's a tough question, or I shouldn't say it's a tough question. It's a couple different ways you can look at it.
Yeah.
So there's not a 5-axis 660, but if we want to add like a rotary trunnion or something like that, that's possible, and that's really pretty darn easy. You could take it from a 3-axis to a 4-axis to a 5-axis with different tables, with different rotaries. And it all depends on the size and the brand. So I can't just spit out one answer today. I'd like to be able to, but there are a lot of options out there. So I don't want to stick my foot in my mouth.
We really want to look at the parts and determine the right size of table for the application. And when you're looking at tables, we deal with a couple of partner companies. Velocity has a 4th-axis table. Lindex, Nikken, Okuma, so Okuma Precision. Yep. But there's different drive mechanisms, and those different drive mechanisms will drive the cost of those tables accordingly. So you have a cam roller gear type system, or you have a worm gear system, and there's a significant cost difference between those two. And those two drive mechanisms are used for different applications. So you really want to look at the application, make sure we're selecting the right table for your needs.
Yep. Next question, any plans of adding a 2APC Okuma unit?
It's a good question. Not at the moment, no.
Now, what we can do, the Mitaco makes a pallet changer. There are others out there that make pallet changers. There's things that we can do, but coming from Japan, I don't think it's been developed yet. It might be in the works, but I personally haven't seen anything. There's another question. Do you have a PDF flyer that you can send us? Absolutely. We have a lot of different information, marketing collateral that we can send you. And I think that was to Dan Holmes. So we're going to have to send that over to you, Dan, after this. Next question is, what's the largest cutter diameter size that we can run in this machine?
40 taper, about 5 inches, 125 millimeters, and 50 taper is 152, so right around 6 inches.
Nice. Thanks, Ron. The budgetary cost for the Cat 40 machine. So these machines are coming into stock now. They'll be available in July, and the starting price for this machine is $230,000. Is where we're starting with these machines right now. And it's quite a bit less than what was the MB66. It's about $80,000 less than the other machine. So we're bringing these machines in. They're dialed in. They've got roughly all the same options, and that's how we're able to keep the price down. Will a riser block be available for this M660 is the next question.
No, not currently, no.
Yeah. Cat 50 version, I just saw a question come in for that. That's about 15,000 more. So we're about the 245 price for the Cat 50 version. All right, I got a couple more questions that are coming in. Does it have HSM? And I'm guessing you're meaning somewhat sort of high-speed machining. That's the question says, does it have HSM? And the answer is yes. I mean, it's a high-speed machine. It starts at 15,000 RPM. Like Brad said, it's got 2,000 blocks of look ahead. And with the High Cut Pro, that's really like a 2.5D software that runs very well. It's you set the tolerance of what you want the machine to hold, and it runs basically as fast as it possibly can to hold that tolerance.
Yeah.
And Brad, you may be able to want to expand on that. I don't know.
I think you hit it pretty well, but yeah, I mean, if you're roughing things out, you'd want to open up that tolerance band. So that's just a very easy thing to set in High Cut Pro. So you open up your tolerance band and the thing rips away. And then on your finish passes, you're going to tighten up that tolerance band to gain some accuracy and precision. And it's as simple as that. That's a standard feature across all of our machining centers, but you hit it pretty well, Greg.
And if you want to take it past 2.5D, you want to go 3, 4, 5, there's a function that we call super NURBS. And that's basically the same thing as High Cut Pro, but it's for contouring. and it works very well, even in 5-axis mode. Another question is, what's the longest tool you can run?
15.75 inches, 400 millimeters.
That was good, Wade. Off the top of your head, man.
Huh?
Nice job. Another question.
400 millimeters to inch in my head.
Yeah. What size tap will it pull in steel?
I believe that's an M36. Ron, could you correct me if I'm wrong on that?
Nope, you're dead on the money. You did your homework.
Oh, come on.
And it's in what? Mild steel, 1045. Yes, sir. So 106 RPM, so we got good torque down the bottom. So it'll take that.
And that's something that's a great talking point. It's hard to do in a video type format, but as people are looking at machines, looking at applications, pay attention to the torque curve. That's a very important piece of the puzzle. People can throw some numbers out there that look very impressive on an Excel sheet or a brochure, but when you look at the torque curve and see where those numbers actually are versus what you're machining, that can paint a different story. So.
Another question came up. Are you sending all of us the propaganda in quotations? We can. We hadn't planned to do that, but yeah, we can. If you guys would like it, we're happy to send it out. We can send out some PDF flyers. Thanks for asking that question. Last question is or I shouldn't say last because they keep coming in, but is a chip conveyor included in that price? And the answer is no. It's not included in that price. It is prepped for a conveyor. And there's lots of options, as you can probably imagine. And we're really trying to keep the price down on the machine, and that's why the conveyor is not included. And there's so many different types of applications for these machines. Okuma just gets stuck with conveyors if we bring in each machine with a conveyor. So it doesn't really work out very well.
Yeah, that's another one that I think people don't do enough research on as far as the right conveyor for the right application.
Right.
If you bring in just a standard hinge belt conveyor and all your machining is aluminum, 3 months down the road, you're going to throw the hinge belt away and bring in a drum filter or some other type of conveyor. So we want to make sure we put the right one on for your process.
Yep. Another one came in. Are both spindles Big Plus? The answer is yes. Cat 40 and 50.
Yep.
As a standard.
And for those that may or may not be, I assume in today's world, everybody knows Big Plus, but Big Plus is a standard started out by Big Kaiser. They actually hold the patent on the measuring device for measuring the dual contact. So a Big Plus gives you contact on the taper as well as contact on the face of the tool. So very important for high precision work, but also for tool life, for reducing vibration, things of that nature.
Well, guys, guess what? We're out of questions, but it was a very interactive session. Thanks for taking your time with us today. In a couple of weeks, we're going to be going over Sagami and talking about Swiss machining and why Sagami and why Swiss, why that can be a game changer for your shops. So be on the lookout for those emails and that video coming up here in the next couple of weeks. Thanks for making our launch. Today was a big day for us. We spent a lot of time, as you can imagine, testing and taking videos and all that kind of stuff. It's been a lot of fun. It's been stressful, but thank you. Hopefully it was educational for you. Really like doing this. And sorry, we're not going to be at IMTS this year, but this is a good way for you guys to get a good education and see what would have been at IMTS. So again, thanks. And look forward to talking with you all here in the next couple of weeks.
Thanks, Greg.
Bye, everybody. Thank you.
Take care.